During this challenging and also changing times, the Institute in Los Angeles and the institutes throughout North America are excited to present a rich program of cultural events online through webinars, exclusive videos, language classes, workshops online, and much more. Today, we are delighted hosting Dr. Cinzia Zuffada, Associate Chief Scientist at the NASA Jet Propulsion Lab in Pasadena, and also the President of ISNAF, Italian Scientists and Scholars in North America Foundation. Dr. Zuffada is also the recipient of the Italian Cultural Institute in Los Angeles Creativity Award for Science 2020, and she was scheduled to speak at the Institute on the occasion of Italian Research Day in April. She has now graciously accepted our invite to participate in this first webinar presenting her research. I would like also to thank all my colleagues, directors of the institutes throughout North America, Luca Di Vito in Chicago, Francesco Darelli in Montreal, Paolo Barlera in New York, Anna Maria Di Giorgio in San Francisco, Alessandro Ruggero in Toronto, and Emanuela Mendola in Washington, D.C., as well as our distinguished speaker, Dr. Cinzia Zuffada and Maria Teresa Cometto. Maria Teresa Cometto is a journalist and an award-winning author based in New York. Since 2000, she has been covering business and high-tech for Corriere della Sera, the leading Italian daily, and she also writes for other important magazines. I'll now pass the presentation to Maria Teresa. Thank you, Maria Teresa.
Thank you so much to the director of the Italian Cultural Institute in Los Angeles, Valeria Rumori, for asking me to moderate this conversation. Many thanks to all the Italian Cultural Institutes in America and Canada for co-sponsoring this event. Thank you all for following us. I'm so excited to have this conversation with Cinzia Zuffada, who is such a great scientist. The director already mentioned that she's the Associate Chief Scientist of the NASA Jet Propulsion Laboratory, JPL. And in this role, I read on the lab's website, she's a key contributor to the strategic planning of science and technology research and development for JPL and to managing institutional internal R&D investments. Additionally, Cinzia oversees a number of programs supporting collaborations between the lab and the academic community as the manager of the university research affairs. For over 20 years, she has led the pioneering Global National Satellite Systems Reflectometry Technology Development at the JPL, and has played a pivotal role in demonstrating the feasibility of the remote sensing technique for ocean altimetry and land hydrology. She is currently leading a research group to analyze data from the NASA Cygnus mission to better understand dynamic processes of the terrestrial hydrology. So a lot of stuff, a lot of accomplishment. Among other things, Cinzia has been also awarded with very prestigious prizes. The Magellan Award for Outstanding Senior Management at her lab, the NASA Medal for Outstanding Leadership, and the Knighthood for Order of Merit of the Italian Republic. Finally, Cinzia is also the president of ISNAF, the North America Italian Scientists and Scholars in North America Foundation, that recently has launched the campaign Italy Stay Strong. So first of all, Cinzia, what is this campaign? Can you explain to us?
Maria Teresa, thank you for the very kind introduction. I'm excited to be here in a conversation with you, joined by the audience across North America. So I'm happy to be here, and I'm happy to start with telling you something about the Italy Stay Strong campaign that started at the beginning of April. we have been supporting the initiative from the Italian Embassy in Washington, D.C. to raise money on behalf of 3 Italian hospitals, one in the north, one in the center, and one in the south, that have been at the forefront of the fight against COVID-19. And these are institutions which also are engaged in research. And so as a foundation of researchers, it seemed that that was the right role for us. And so we were very glad to support the embassy. And I can say that we feel that we have been very successful. Thank you to everybody who has already donated. We have seen an enormous support, many contributions. I want to show you very briefly where we are with the campaign. As of today, this is a report from the GoFundMe site. It shows that we are halfway of our goal of $500,000. Actually, we have received more than what is shown here because some donors chose to donate directly to ISNAF on behalf of the hospitals.
So, for friends, sorry, Cinzia, for friends who want to fund this campaign, where do they have to go?
The GoFundMe, and then they will search for Italy Stay Strong. They can also look at the site and search ISNAF. This is the only GoFundMe associated to ISNAF at the moment, and they will be able to find it very easily.
Okay, great. So be generous, go to the GoFund campaign and help the research in Italy to fight the coronavirus. And by the way, the research, it will be very helpful worldwide, I mean, for any other country. The title of this conversation is A Reflection on the Earth Viewed from Space. It's a reference to the reflectometry technology that Cinzia has developed at her lab and to the considerations about Earth that are possible thanks to those techniques. But first, let's talk about Cinzia's personal and professional journey that started in Broni, where Cinzia was born and grew up. Broni is a small town in the Oltrepo area of Lombardy, where they make very good wine. I know because when I lived in Italy, I used to go there to buy my wine. Cinzia, is there anything or anybody who inspired you to become a scientist?
Well, this is a question that could have a very short answer or a very long answer. And so I wanted to take the opportunity to show a few images here from where I come from. You know, we have said small place, Broni, it's on the hillside. I also want to introduce the notion of water here, since I'll be talking about wetlands. So something that is, in a sense, my background. And I would say I credit very much this environment of semi-countryside as I was growing up for being conducive to, wanting to explore, wanting to learn. I think it's a beautiful environment for experimentation, right? The country, particularly for a small child, gives that opportunity of freedom. And this is exactly what I remember, the almost daily discoveries, and sometimes even inventions. So for example, I think that it starts there.
Yeah, Cinzia, can you give us an example of an invention or a discovery that you made while you were a child, roaming the hills
Yeah, I certainly can remember as a very small child the sense of wanting to classify animals. right? Beginning with insects and having the sense of setting up what was then the concept of a zoo made up of, you know, a few butterflies and grasshoppers and this and that. And sort of wanting to see somehow how they were all related, right? Finding the eggs of lizards, something that I wouldn't be able to do anymore, but I used to.
Yeah.
And so that's what I'm referring to as experimentation, discovery, observations. That's very much what I was doing all along. Inventions, I certainly recall, you know, concoctions that were produced out of wild berries, and even attempting to use them as ink. Something that, you know, I'm not sure how successful that would have been, but at the time it certainly seemed very cool.
I hope not dangerous.
No.
However,
no, I don't think so.
Yeah. However, when you went to Pavia to study at the University of Padilla, you chose engineering, and you got a doctorate degree in engineering. Why engineering?
So I was attracted to a number of subjects as a student, and I certainly wanted to have the opportunity to get an education that was forward-looking. So even then, you know, while growing up in a situation where the world was a lot smaller than what it is today, and it has been for a long time, where the opportunities were relatively restricted for somebody of my, you know, socioeconomic background. I did not have a whole lot of opportunities, and so I saw education as my, you know, social elevator, very much my social elevator. And so I thought that with a laurea in engineering, I would have many paths open to me. And so I invested those years at the university in a very formal type of environment. I have here the pictures of a university college, Ghislieri, which is a, you know, nearly 500-year-old institution. It had just opened its doors to women a few years earlier than my arrival. So in a sense, you know, things were harder then because of the somehow the rules of the Italian education at the time. These things were true also elsewhere, not just in Italy, but they were certainly true for my generation.
Yeah. Well, however, you didn't think of becoming I mean, an engineer building things, but you were interested since the very beginning to research, I understand. And in fact, you started as a researcher at the University of Pavia, and then you moved to California to be a researcher at the Caltech. So how was your transition from Pavia to California?
Well, it was a very, you know, a very shocking transition. I definitely was not prepared. As I said, at the time, there were very few collaborations, certainly no institutional collaborations. So there weren't groups already.
From America and Italy.
Right. Mm-hmm. And so it was, in a sense, you know, as they say around here, a sort of jumping in the water and learning how to swim as you went along. And it was, again, it's the journey of discovery. So in a sense, I sort of continued at some level, you know, following what had been my path all along without a whole lot of support, well-identified organic support, but building my experience sort of gradually. The experience was also enriched by my professional experience, right? I ended up marrying, and in doing so, I also, in a sense, settled into an environment that gave me many more aspects of the place that I was coming into, and that became part of my background, right?
Yeah. Since 1992, you've been working with the Jet Propulsion Laboratory. That is set about 20 miles north of Los Angeles. What is the purpose of this lab?
Yeah, so this is, I want to show you an image and show the audience an image of JPL. You see here, it's a laboratory nestled in the San Gabriel Mountains. And it is a federally funded research and development laboratory. So it's a laboratory that belongs to NASA. In other words, we are a federal research lab that NASA wants to invest in for the long time. These are some of our neighbors that I'm showing. It's a place that where nature abounds, and we need to coexist with nature. So the picture of the fawn and the babies, I took it myself outside of my office. So they are definitely very close. They are around. The picture of the bears, it's not mine, but they are very common sightings, particularly in gardens with fruit and barbecues and swimming pools. So they are also not uncommon. So the laboratory, going back, is, let me tell you something about the history there of the laboratory. The laboratory was originated as, in a sense, a yard of Caltech, the university that is my employer formally, where students who were working on research contracts for the Army, working particularly in the 30s originally just in weaponry, and then moving on to the early rudimentary technologies of jets before the war. So they used these as ground for experimentation. And the money from the Army kept coming in, and JPL at some point acquired its own name, Jet Propulsion Laboratory. And they were at one point also working on jet propulsion, which they are not doing anymore. They haven't been doing for a long time. Anyway, JPL really made it big with the launch of Explorer 1 at the beginning of 1958. You can see a picture here. So this is the first American satellite for scientific exploration. And it was launched a few months after Sputnik. And although, Sputnik was shocking because of what it brought into the world, Explorer was equally revolutionary because it started the era of space exploration for scientific purpose. And soon afterwards, NASA was created. In fact, a few months later, and then by vote of Congress, it was delineated, passed at the end of that year, 1958. The Jet Propulsion Laboratory was already an entity, and it chose to remain under Caltech. It chose to remain a part of a university, and we have had this identity ever since, although the university has a contract with NASA.
Mm-hmm.
So we work for NASA under a university, and it's known for space exploration by virtue of unmanned vehicles, so what's called robotic exploration. And it operates in all disciplines. JPL is very well known, starting with the Voyagers, which are still active. They have left the solar system, so the only man-made bodies outside our solar system. JPL is active in, of course, the planetary exploration, in particular the exploration of Mars, where we have a lot of assets, a big rover currently roaming Mars, and another one to be launched, I hope, this summer. And also a very strong program of Earth exploration. So JPL is the home of a lot of missions to planet Earth. So missions who look at the Earth from a remote point. And this is where we are going then with my research.
Yeah, just a second, you mentioned Mars, the exploration of Mars. What do you think of the plan of Elon Musk to send a man, send a colony to Mars? And by the way, NASA takes seriously Elon Musk, because they just gave him a bigger contract to for a study about bringing back the man on the moon. What is your take about Mars? Are we going to colonize Mars sooner or later?
Well, this is definitely a goal. It is a goal, and you know, the colonization of Mars, it's a recognized, identified goal for NASA, as well as a personal goal for Musk, right? So he has founded SpaceX on this type of goal, right? So Musk, of course, has embraced his own paradigm of development. SpaceX is doing very well. So it is this company that has been awarded the most recent award to do a lander for the moon. The colonization of the moon is a stepping stone on our way to colonizing Mars. So it's viewed as a logical stepping stone for us to learn how to actually set up a colony to a body outside of the Earth.
Yeah, that's fascinating and so exciting. So now about your own mission. At the lab, you have been working especially on remote sensing. Can you explain to everybody what it is about?
Yes, yes. I want to talk about remote sensing of the Earth by starting perhaps with an analogy that is talked a lot about these days, unfortunately in connection with COVID-19. And that is, you know, a remote sensing means that somebody is making a measurement without contact between an instrument and the body you are measuring. And so these days, I think everybody has been reading about sensing the temperature remotely, right? Our temperature, the human being temperature remotely, in connection with you know, the ability to determine whether somebody might have a fever and therefore protect the individuals from perhaps a contagion. And so it is really the same principle here, but in my case, the patient is our planet, right? And so, but we are observing this bigger patient from afar, and we are observing the planet and making a set of measurements from the vantage point of space, and using equipment that is deployed in space. So in general, remote sensing can be done. It requires a source of energy. This source can be natural. So the sun is a perfect source of energy. It irradiates the Earth. It's constantly there. The Earth reacts to the presence of this energy, and different parts of the Earth react differently. And so if you have a system, if you devise a system that has instrumentation that is sensitive to the signature produced by the different parts of our Earth, so that is our system, there you have you have made a remote sensing, a remote measurement. And this is exactly what the community has been making now for a long period of time. Other sources are man-made, where you have something that is also in space and is a source that is used to shine against the Earth. And then you have a way of getting the response from the Earth, which varies depending upon what component of the Earth is reacting to that source. And so you can have passive and active remote sensing.
Yeah. Well, I read on your website, the website of the lab, that there was a special moment in October 1999 at Crater Lake in Oregon. You led a special experiment that was a groundbreaking with groundbreaking findings. Can you recall that moment and what it means?
Yes, and before I go there, actually, so from this very introductory concept of remote sensing, then I want to show the audience an illustration of what is a traditional way of doing remote sensing. This is a radar, right? It's an existing radar, but for the purpose of this conversation, it just represents a traditional system of remote sensing. It's a very complex system. It's also a very expensive system. It measures characteristics of the Earth. In this case, we're talking about the humidity, the Earth humidity everywhere, and very well. But it is very expensive and very complicated. So many years ago in the 90s, I became interested in looking at new techniques, alternative techniques. So in a sense, what then became known as disruptive technologies and techniques, right? Mine was definitely disruptive at the time. And this was predicated upon no longer a design system like this radar has been designed for the measurement that it's supposed to make, but rather the exploitation of some signals that are there for some other purpose and that are called the signals of opportunity. So they offer an opportunity to do something else. And so the first type of signal that was targeted for this is really the signals from the GPS. The Global Positioning Satellite, which is a system that has become operative in the 90s. It's a constellation of 24 to 27 satellites. We all know that. We all utilize GPS in our daily lives. GPS has been utilized for purposes other than the positioning for a long time. In fact, since the 90s, to do science with GPS. In particular, the first type of application was to measure very small movements in the Earth crust associated with seismicity. This is the reflectometry that is a totally new idea that made its debut actually in Europe in the early 90s. And the idea was to utilize these signals as a way of creating a measurement, a global measurement of the sea surface. So for the purpose of doing altimetry, as well as other characteristics of the ocean surfaces. The idea being that the signals are there all the time on these satellites that will be there for a very long time, right? Nobody's talking about dispensing with the global satellite systems. And so if we have a way of designing a system of receiving signals after they have reflected off the Earth, we can, through the clever use of this reflected signal and the development of a lot of algorithms, basically reconstruct the topography of the surface of the sea, which is a variable quantity, right? The topography changes. There is a dynamic topography. It's subject to a lot of variations that the oceans go through. And this is how the notion of reflectometry started. And when it started, we didn't have these receivers in space, right? It takes some convincing. And so the way you do the convincing is that you start with some modeling, some feasibility studies. Then you start with some experiments. And the experiment that we came up with to prove the notion of altimetry was from a lake. And so we went all the way to Crater Lake, because Crater Lake, being indeed a lake on a crater on Earth, is very low within that crater. So we have quite a height of the rim of the crater over the body of water. And this is helpful to be able to separate the reflection from the direct signal that comes in. And so we had this experiment there at the end of 1999 that was done.
Yeah, Cinzia, were you there at the top of the crater?
Of course, I am the person with the red hood.
Yeah. Did you hike to the crater?
Well, yes. As a matter of fact, this photograph does not give you the right sense, but here we were on a cliff, and we were deploying.
What did you demonstrate in a few words?
We demonstrated that we basically measured the height of the surface of the lake, and over time, using reflections with the GPS system. So we had a receiver that was installed in this crop of rocks that you see there, which is a cliffhanger, and the receiver was pointing at an antenna pointing towards the surface of the lake. So it intercepted all these reflections. The reflections are there all the time. Obviously, you need to catch them. So you need to have an antenna in the receiver. And this is what we had. And all of this was an experimental setup that was created in a laboratory. It wasn't a dedicated instrumentation. So we were in this group of people over 2 days and 2 nights, because of course the reflections happen 24 hours a day. And we collected a lot of data, which we subsequently analyzed. And this was the time when, we basically proved that you could do this new measurement, and therefore, you could, in a sense, continue the pursuit here. Yeah. And this is what happened.
Yeah, I know that other very important tools of your research and your work are the new very small satellites.
Right. So at the time when we were when we were looking at the reflectometry and we were making this experiment, of course, we were also thinking about other things. And in particular, we were thinking about an experiment in space. And so back, the reason, this was possible is that miniaturization was showing up, so that you could go from the large size of this traditional remote sensing measurements that I talked about earlier on in this conversation. You could move to something much smaller. And so back in the year 2000, early 2001, we had actually made a proposal to NASA for a small satellite that was done in a team, including a University of Colorado in this case, that would have done an experiment utilizing the reflections to do altimetry, as well as all the other characteristics of the ocean surface, including the roughness that is caused by the winds. And this was, way, way ahead of its time. We competed. We were finalists in this competition for NASA, but it was eventually not awarded. So evidently we were too early, and it took some more convincing to do. And that convincing lasted more than 10 years, until in 2016, NASA launched a mission called Cygnus that has now 8 small satellites. The satellites themselves are on the same plane, so they are one after the other, and they move and cover the Earth continuously. And so they have receivers on board. They have 4 antennas each, so they can capture at any given time 4 reflections. So it's 4 reflections, 8 satellites. That's a lot of measurements in a latitudinal band that covers the tropics around the equator. And this mission was proposed to measure winds, high intensity winds that are connected to the intensification of hurricanes. So NASA selected this mission, and it launched at the end of 2016. And I've been working as part of the science team of this mission ever since. And even before, during the development of the mission, I was also on the NASA review board while this was being built and tested and validated.
Yeah. You mentioned, Cinzia, you said that you are particularly interested in wetlands. So from the space, what do you see? How are they changing? Why is it important to monitor these ecosystems?
Yes. So I want to say that once the Cygnus mission launched, of course, we started analyzing the data and looking at, the sea surface topography and looking at the characteristic of the winds. But there was something there that we observed that was not anticipated. And that is that the reflections are particularly strong from the surfaces on the land that have water on the surface, so the wetlands. And this was a sort of consistent. The mission had not been designed to look at wetlands, but it ended up doing so. And this is not the first time that something like this has happened. There is a proposal to do a study, and then the study reveals a data type that then causes the science community to want to look at other things. That's exactly what happened here in Cygnus, and it's still happening. And so what I'm saying is that these reflections here are very strong when we have water on the surface. So now I'm going to show you some results that are the result of our work with the thickness data. So we are looking at here the peak power. You know, the reflections are basically an energy. It has its own characteristics, and so it has a maximum value, the peak power of the signal. And the peak power accrued over a certain period of time over an area gives you a map. So a map of how the surface that is underneath responds. And so in this particular case, I'm showing part of North America and South America in the latitudinal band that Cygnus is observing. And it shows that you know, it is a map of the hydrological characteristics of the area. You see that the Amazon region is captured very well. It describes then the distribution of the rivers and the bodies of water of this area. So as we are monitoring it as a function of time, we can see its variations. And so that's the ability of this technique to measure something and measure it dynamically over, in this case, a large portion of the Earth. It's not the entire Earth, but it's a large portion where there are a lot of wetlands. And so why do we want to study wetlands? Well, we want to study wetlands because they are a very important part of what we call the Earth system, right? There are lots of wetlands. They have their ecosystems. The ecosystems support life. They support communities, and they have certain roles on Earth depending on where they are. And by the way, a type of wetland that we are all very familiar with are rice fields. And here I go back to the wetlands of my youth around Padilla. So the other big thing about wetlands is that they are associated to the production of methane. The release of methane is something that we are all very interested in, because methane is a very important greenhouse gas. It's very powerful. It's a lot more powerful than CO2. So there is a lot less right now, but if methane increases, it's bound to make a significant impact to the temperature of the atmosphere. And so we want to monitor that.
Yeah, Cinzia, you said at the beginning that from the space you can measure the health of the Earth. So what is the health situation of the Earth?
So the health situation of the Earth is, in this particular case, the case of the wetlands are disappearing, right? And so they are disappearing, and one source of concern is, speaking about health, is the equilibrium of these ecosystems that I was referring to. Everything is changing. There are repercussions. And the other thing is, of course, the production of methane. The production of methane itself is governed by certain processes. Not all of them are fully understood. So we need to be able to measure this over time. So we are looking at changes. And whenever there are changes, of course, the planet gets out of a state of equilibrium. And we need to study that and understand what is going on, what are the causes, how it impacts the rest of the Earth system.
Yeah, well, one good news about space and Italy is that the aerospace industry in Italy is growing a lot. It's big. There are about 250 small and medium companies making a lot of things, including very small satellites. There is also a startup called Leaf Space that provides services for microsatellites, and who knows, maybe one day could collaborate with NASA. Leaf Space was founded, for example, by 3 young engineers, alumni of Politecnico of Milan. Do you, Cinzia, have any project going on in collaboration with the Italian universities or research centers in Italy?
Yes, actually, both at a personal level, you know, I've spoken about my personal research projects here, and then as a representative of the laboratory, speaking for JPL at large. So, yeah, we are involved with a number of universities. We do collaborate on data analysis, in this case of sickness. We do work, we do engage with graduate students. So some of the graduate students from Italy have come and spent some time at JPL working on these joint projects, publishing together, going to conferences. So it's very successful, something that I look forward to doing more. And at the laboratory, we are working, you know, JPL has a long tradition of working with the Italian Space Agency on a number of projects. Some have been very big projects like Cassini, where, you know, Italy contributed so much, both in terms of instrumentation technology and also science. So a real big event. Most recently, the Juno mission, Italy has contributed a spectacularly good instrument. And, you know, we are seeing science results that are, again, opening up the front of what we know about Jupiter atmosphere. And there are also things in the works. There are projects that are being discussed right now in Earth science that I am aware of that would see a collaboration between Italian groups and the Jet Propulsion Laboratory for NASA missions together. So I think that we are going strong, and I believe that in the future we'll continue to be very strong.
Yeah, talking about Italian researchers, there are so many in the United States and in Canada, thousands, I think. And ISNAF that we mentioned at the beginning is the organization of Italian researchers and scientists in North America. Can you explain what this foundation do?
Yes, the foundation, the Italian scientists and scholars, so the emphasis, let me put the emphasis on scholars, is really an organization that it's a network to connect the community. It's a large community, widespread, empower the community by doing so. It's also a community that shares some common characteristics. Like, we are all Italian and born and educated in Italy. So we have certain cultural features that are in common. And we want to celebrate those, right? We also want to celebrate the professional successes of this community. And by doing so, also build bridges back with Italy and give back. Recognize those that whose contributions are outstanding, and also help the newer generations who are coming to the US, coming to North America to work for a period of time or looking to relocate, we want to give them a hand to help them get situated, get established, receive some mentorship, and enable them to be successful. And by doing so, give something back to Italy.
Great. Talking again about your career, in 2014, as I mentioned already, you received the JPL Magellan Award for outstanding commitment to foster gender equality in science. What are the main obstacles that you had to face as a woman and scientist during your career?
Well, the many, and you have used the past tense, but you know, these are still going on and occurring more or less as we speak. And I believe that there will continue to be there. However, this being said, there has also been a recognition that you know, a commitment in organizations such as mine to want to be more fair, to want to act in a manner that is more proactive about recognizing the contribution of women, right? And so in the past 10 years or so, we started with having a website that was dedicated to the contribution of women in research, to having notable speakers come and speak, you know, from various communities, to now the institution having you know, more a more directed, a more concerted effort to make sure that there is parity, there is really equal opportunity, and it's sort of measured. So we have gone from a situation where it was not measured to one where there is the need to measure it and do something about it. So I think this is a big result in less than 10 years in my experience.
Yeah. Before going on, I invite everybody in the audience to send your questions either through the chat application or to the question and answer portion of the Zoom, or even as a comment on Facebook. So please send your questions. Well, talking about women and space, I'm curious, have you ever met our Samantha Cristoforetti?
Yes.
Oh,
yes.
really?
Oh,
When?
yeah.
How was it?
I met Samantha at JPL last year. She came and visited JPL and was with us for an extended visit. She gave a talk. It was well attended, and she was very happy about the visit. She wrote to me at the beginning of this year saying that the visit to JPL last year was one of the highlights of her year. So I felt really very happy because Samantha is a very special person. So
what impressed you more about her?
Oh, just you know, nothing in particular. It's the entire person that is impressive. Mm-hmm. It's just her overall demeanor that is impressive. So a very special person.
Okay. Carol from the audience asks if it is possible to get a copy of your video presentation. How can you provide?
I believe it is, and we will find a way of posting it to either the IIC site. So yeah, we'll do.
Okay, great. And I think that anybody can ask the Italian Cultural Institute of Los Angeles to help get. And also I think that the conversation is recorded, and sooner or later it will be available on YouTube, the YouTube channel of the Institute. Another from the audience, Alessandro asks whether the Cygnus mission could be employed to measuring the melting of permafrost in Arctic regions?
Yeah, unfortunately, no, because of the orbit of Cygnus, since it was designed to measure the intensity of winds in connection to hurricanes, the tropical latitudinal bandwidth was chosen. And so there is very little permafrost that Cygnus can fly over. But in principle, yes. And in fact, there have been other experiments, not with Cygnus, but with another mission, a small satellite from Europe, that has shown that indeed it is possible.
Mm-hmm. A question from Justine. Can you please elaborate how research by remote sensing shows how pollution from human activities is causing harm to people and to a myriad of organisms? Justine was amazed by the NASA JPL research on how air pollution was reduced in China during COVID-19.
Yes, so NASA has actually a number of missions currently flying that detect air pollution and detect how the pollution moves and crosses continents, right? So the dynamic of pollution, how it changes, and in particular, how it changed with the COVID-19. I also want to say that there is a mission now in development at JPL, which is called Maya, that will be measuring particulates in the pollution. And so there will be, as part of the NASA mission for the first time, as part of the mission itself, there will be some epidemiological studies that will be conducted by some people in the science team. And so it's the first time where in the proposal, there weren't just the scientists, experts in pollution, but there were also people that are interested in getting this data and look at the effect of such pollution on individuals. And Italy plays a role in Maya because one of the calibration sites for Maya is in Italy. It's in particular, it's Rome, and the second site is being studied in Bologna. So there are two laboratories there that will work jointly in this mission, and there are people, epidemiologists from the region of Lazio, who will use the data in specific targeted studies. And I thought I would mention this because we've been talking about collaborations, and this is one perfect example of a collaboration that I think I look forward to because of the strengths in the two communities.
Yeah.
Maya will launch in a couple of years, so stay tuned.
Great. Cinzia, you mentioned that wetlands are disappearing. So Paola is asking where the largest wetlands are still exist.
So there are very large wetlands in the tropical regions. We have seen, of course, the Amazon is a very large wetland. We have wetlands in East Asia, right? There are a lot of wetlands in Vietnam. There are wetlands also in Northern Australia and in Africa. But this being said, their areas is being reduced because of man-made activity, particularly the arrival of agriculture.
Mm-hmm. Yeah. Well, Stefano asks, for the younger audience, does JPL have any program of interest for local high school students with interest in space engineering?
Yes, JPL has actually a lot of activities in terms of tours, classes. And we have conducted these tours all along. Of course, everything has been stopped because of the situation with COVID-19, but I do hope that they will resume. And then, of course, we can have also targeted visits. Those can be organized with families and children. And JPL also has had traditionally a JPL open house in May, which is a very, very successful event. And one of those which unfortunately cannot happen right now, but in the future, once this is over and we will go back to some normal life, they will come back.
Great, so stay tuned. Another question related to COVID-19. Farah would like to know whether notable changes in methane production have been observed or are anticipated due to the reduced emissions arising from COVID-19 isolation.
No, not to my knowledge. The methane production, again, you know, coming from wetlands is independent, right? It's not one of the pollution products that are associated to transportation, human transportation. So sources of methane, in addition to wetlands, are also cattle. The burp of cows produce methane. It's a well-known fact. And those also have not been significantly impacted by the COVID-19.
Mm-hmm. Yes. Another question from Anna. The precision of pollution measurement from space is comparable to the direct measurement on the land. Which is the advantage of space measurements?
So they are two different things. And I would say that overall they are comparable once one takes into account how you make the comparison, right? So the primary advantage of a measurement from afar, a remote sensing measurement, is that the measurement is global. And so you can measure everywhere at any time. And therefore, you can construct sequences, maps, as I've shown in particular cases. And this is necessary to monitor something that big and that complex as a planet. Now, measurements done locally are actually very good and very important because you can more easily interpret the measurement. And so they serve as a basis to validate and verify that what you are doing from space is correct, is the right thing.
Great. Any other question from the audience? Waiting for somebody else to ask a question. I go back to the topic of women in science. How do you think that young girls, young women can be inspired to have a career in science? How can we improve the number of women in science?
Well, you know, to some extent, I think that the most important thing really comes by placing good expectations on women, right? So there should be the same high expectations placed on young girls as there are on boys. It would start there. It would help develop, you know, young girls. It helps give them a sense of, you know, wanting to invest in their career, in themselves, and most importantly, having a good sense of themselves and of their abilities. And I think that what is very important really is how this is approached at an early age in the families and through school and with all of the interfaces that young people have.
Mm-hmm. Yes. So I don't see other questions. Ah, okay, one. Antonio asked if the methane is usable commercially, the methane from the wetlands.
It is not, it is not harvested. Let me put it this way. So the methane right now is released into the atmosphere. And this is the dangerous thing. So you could, in principle, construct an experiment whereby you harvest that methane, but it's like the harvesting of CO2, right? It's not done right now. So it's an emission of a gas into the atmosphere that can lead to significant temperature increase.
I see. Okay, so my last question before, another one. Alessandro asks, can Cygnus track the melting of mountain glaciers, for example, in the Andes? So
yes, it can. There is one caveat for this measurement, and that is the footprint. So the footprint of Cygnus is possibly too big for this kind of features. But in principle, it passes, and so it can image the Andes. You can have surfaces with high reflections there. And that's certainly one application that this mission could be directed at.
Okay, great. So I think we have covered so many topics, so interesting. So last question from the audience comes from, again, Justin, and it is this one. Which universities, businesses, and think tanks in Italy are leaders in sustainable development? Italy was ranked at the top from green tech. Does remote sensing of Venus help us understand likely effects of more pollution on Earth?
Well, the pollution areas in Italy, so the primary pollution areas in Italy are in northern Italy, right? The Po plains. Those are big sources of pollution. In terms of Venice, given that it's in a sense more removed from the agricultural areas of the Po River, it's a different situation in terms of, the pollutants there are possibly of a different nature. That is to say, in the water, and they might have an effect in the interaction of the water with the rest of the system in the old city.
Mm-hmm. Yes. So my last question before asking the director of the Institute to close the event is, you said that, Cinzia, that ISNAF, one of the mission of ISNAF is to mentor new young researchers. So what is your advice to a young Italian researcher, woman or man, starting this career?
My advice is to make sure that, to take advantage of the tools that exist, that are in place. ISNAF is one network that indeed offers a lot to somebody that is new to the United States. And both in terms of getting situated locally, right? Learning about maybe the immediate environment, as well as getting targeted advice of a professional nature that can help lead them as they move along and be aware of opportunities and learn faster. So I would encourage them to want to come and connect with ISNAF, take advantage of what we have to offer.
Great. Valeria Rumori, do you want to say a few last words?
Yes,
yeah,
of course.
Yeah,
I love
thank Cinzia and all the audience for this wonderful presentation and all the questions. Valeria.
Thank you so much, Cinzia, and thank you so much, Maria Teresa, for accepting our invites. Thank you also special thanks to my colleagues, my colleague directors all over the North America for their collaboration. And we do hope that you all enjoy this enlightening and really captivating presentation. And we invite you to follow us on our social media, visit our website, and sign up for our monthly newsletter to receive updates regarding upcoming online events and webinars. Thank you all, and have a wonderful evening.
Thank you.
Bye-bye.
Bye from Los Angeles.
Bye.